All right, guys, today we're going to expand our two-step equation solving to problems that contain decimals. So we're going to be in your paper packet today. We're going to start our notes and example on page 17. You're also going to need a calculator, preferably the graphing calculator, but really any calculator will do for today's computations. And then obviously you'll need a pencil. So if you need to take a minute, put yourself on pause, grab the materials, and then we'll dive right in. All right, so before we actually start on page 17 with examples, let's just take a quick refresher since we had a couple of days off here. And I just want to remind you of the procedures and steps that you follow when you're solving a two-step equation. So again, an equation has an equal sign. Some of you prefer to draw this little kind of barrier divider line, which is totally fine. So we have a left side of my equation equal to the right-hand side. So the first step that we've been practicing is that you locate the side with the variable. That's where we're focused in on, because again, our goal of solving an equation is to get the variable, or x, by itself. It's a two-step equation because if you notice here, you have two numbers or two relationships with the x here. I've got a subtraction of 3. So if I cover up real quick this, I have x minus 3, right? And if I cover up this back end and I just kind of even highlight this area, this is 3 times x. So you should see subtraction and multiplication of two different numbers here. So we have to get rid of them. The first thing we do after we locate the side of the variable is we want to remove the addition and subtraction you see. Here is our subtraction portion, x minus 3. So we want to get rid of it or undo it. So we're going to do the opposite, which we're going to add 3 on both sides. Our opposites cancel. Our 3x comes down, and then we're ready to do the computation. 15 plus 3, which is, oh, I made a mistake there. 15 plus 3, which is 18. Then from there, we undo the multiplication and division. We kind of talked about it a little bit earlier today, but this is multiplication, 3 times x. So to get rid of it, we're going to divide. We're going to divide on both sides by 3. So hopefully the process is coming back to you here. And then 18 divided by 3, come back over to my calculator here, is going to give you the value of 6. So again, these steps, we're going to follow the exact same procedure and steps. The only difference is we're going to have equations that are going to contain decimals. All right, so in page 17, you will see these 4 examples. We're going to go through them. At the top of your note sheet, just says, oh yes, we can also have decimals, people, in our equations, but we're going to work through them exactly the same, following these steps. Locate the side with the variable, move addition, subtraction, and then rewrite. So if we take a look, I'm not sure if we need this or not, but I'll try to make it a little bit smaller and move it so you can see it on this. I did not mean to do that, if we need it here. All right, so taking a look at this top left example, I'm going to make it a little bit bigger. All right, so top left one here. I'm going to look for the side of my variable. Which is on the left-hand side. Looking at my two operations, I have a plus 8.7 going on there, and I also have a multiplying of 0.5. So again, following the steps procedure here, we're going to get rid of the plus 8.7 first. So this is the part I'm going to get rid of first. In our steps, it comes next. So again, let your calculator do the calculations. The procedure is exactly the same. So we're going to subtract 8.7 on both sides. Minus 8.7 is 3.65. Opposites cancel. Here's my equal sign. And I still have 0.5x. From here, this is multiplication. Anytime you have a number buddied up directly with a variable, it's multiplying. To get rid of it, we divide. So we're going to go ahead and divide by 0.5 or 0.5 on both sides. And again, leaving our x behind. Cancels. Inverse cancel. And we get x equals 3.5 is already in your calculator over here, guys. So you can just go ahead and then continue your operation here. So we're going to divide. You'll see it pops up on the screen there as answer. That's meaning my answer from the previous problem. So 3.65 divided by 0.5. And it gives us the answer of 7.3. Okay, look at the next one here. So again, following that same steps procedure, here's the side with my variable. I want to undo the addition subtraction first, and then take care of multiplication division. So the addition subtraction you should see in there, right there. Let me make it, oh, I'm all over, sorry guys. So here's the addition I want to undo. So I'm going to subtract it on both sides. So subtract 7.42. Opposites cancel. We're going to bring down z divided by 3.2. Now it looks like a fraction, right? But remember, fraction is the operation of division. So it's a variable divided by 3.2. When we do our subtraction over here, we have 9.81. Subtract 7.42. You get 2.39. Then from here, hopefully you notice that the second operation you see here is a division of 3.2. So to get rid of it, we're going to do the opposite. We're going to multiply by 3.2. Again, opposites cancel, and we'll adjust my variable of z. When I perform this operation again, 2.39 is already in my calculator. I'm just going to then multiply by 3.2, and you get 7.648. Okay, bottom left. All right, so if we kind of focus in on the side with the variable, that's always step one, right? Here's the side with your variable. Now guys, this actually still is a two-step equation. When you initially look at it, you might not think that because you only see one number with the variable. Because it's a subtraction of r, that would mean a negative r. So if I just kind of even, again, focused in on just the r, it's a negative r. Oh, I don't know why it will not let me do that. It's a negative r, which when we get variables by themselves, even if I get rid of this 8.28, we have a negative r, and we want our variables to be positive. So this would be an example where you would want to, it's actually a negative 1r. So we're going to go ahead and put a 1 in there. Not like that. Stick a 1 in there, guys. There you go. All right, so now we've got actually two different kind of relationships, two different variables. So we've got a addition of 8.28, and we have a negative 1 times r. Now it is a little bit trickier because these are the kind we don't like. This looks like subtraction, I know, but if you are thinking about terms, we always look out to the front of a term to determine its operation or its sign. The negative, although you might look at it more as like a subtraction, is actually attached to the back end. So a subtraction of 1r. But 1 is being directly buddied up against with my r, which represents multiplying. So that sign then, and again, is out to the left of a number. Kind of think of it, if I told you to write a number 2, you would never do this. We look at the signs out to the front in order to tell if it's subtraction or something like that. So when you have just a 8.28 hanging out, it's out front, it's the leader of the pack, so you don't see the plus sign with it because you really don't need it. All right, so that being said, again, those are the more tricky ones. If you're a 9th grader, you are going to be a little bit more tricked by that. 10th grade, hopefully you start to get a little more comfortable. So we're gonna undo this part first. The 8.28. So again, it's a positive number. I'm going to undo it by subtracting. Sorry, guys, this was not supposed to be there. It's just supposed to be a 5. It is correct in your packet, not on my screen. All right, there. So we're going to subtract 8.25 from both sides. Again, opposites cancel. Don't lose that negative 1. Bring it down. 5 minus 8.25. 3.28 gives us negative 3.28. My last step, again, this is multiplying. That is happening between my -1 and my r. So we're going to get rid of it by dividing. That is my opposite operation. You can throw it in your calculator here, divide it by -1. Or you can notice two negatives make a positive. Any number divided by 1 is equal to itself. But either way, you get the answer of 3.28. All right, last one here on the right. So the only real difference with this one is that if you look, your variable this time is on the right-hand side of your equals. But it's set up a little bit more traditional, in fact, that our term, the first term there, is with my variable and then plus or minus something. So once you realize it's on the right, everything else should be kind of standard. No tricks like the third one there. All right, so from here, you should notice that you have a addition of 1.48, and then we've also got multiplying going on with my variable. So yellow part comes first. We're going to subtract on both sides. And opposites cancel. We can cancel that out. Go ahead and bring down your 3.2p. Using the calculator for our calculations, you get a -6. Then from here for the second step, if you remember I said this was multiplying, 3.2 times p. So our opposite operation would be to divide. We have -6 in our calculator. We divide it by 3.2. Get -1.875. So those are your 4 examples for today. You can take a picture, or I'm sorry, you actually are not taking a picture of this today. So these are your notes and your examples for you to refer to. Hopefully just provided you some more practice with following the steps procedures here, locating the side of the variable, moving addition, subtraction, and then moving multiplication and division. Your assignment is posted on the assignment tab, so you can write down your problems and submit a picture when you are finished. Reach out if you need any help, and I do encourage you to use the graphing calculator just so that you have a little bit more practice with it, and expect decimal answers, guys. We're working with decimals, so you're going to get those type of answers as well. So good luck. Reach out if you need anything.